This is the third indexer benchmark test. So, just to review, if you haven't watched the previous videos, we're talking about this repository on github.com/Chris Troutner, that's me, /benchmark-BCH. That's where this information is getting stored. If you go there, you can click on the link to the docs, which then there will be a link to this second test, the second benchmark test, which tests an indexer's ability to rapidly update its database in order to spend UTXOs. So as a UTXO gets spent, that entry that represents it in the indexer's database needs to be deleted, and then the new entry needs to be created, which represents the new UTXO. So this test really tests the indexer's ability to update its database as UTXOs on the network are being rapidly spent. So think about like a power user who's playing Satoshi Dice or a poker game and is rapidly receiving and spending UTXOs. So I've already done two tests. The first test was against a self-hosted blockbook indexer, and that had an average time of 1.4 milliseconds between spending a UTXO and then seeing the next child UTXO update and getting the information from the indexer so that the wallet could spend it. And this is averaged over 200 transactions with 250 milliseconds in between each try. And then I also ran this against OpenBazaar. They have their own fork of Blockbook, and ran it against their public API, and it came back as 2 seconds between transactions. This test is going to be run against the Ninsight indexer created and managed by Bitcoin.com. And let's do it. Okay, so a few things I'm supposed to do before I run the test is compute right here, last 7 days of daily transaction volume. There's a link to the 3-month chart. I already put that in a spreadsheet here. For the last 7 days, the average daily transaction volume has been 48,000, pretty much on the nose. And yeah, everything else stays the same. I've pointed the test at the Ninsight indexer, and I have these two wallets already prepared, and so I think I can just run this. Cannot read UTXO of undefined. Okay, I need to debug this. Okay, I think the problem there was I needed to install my NPM dependencies, or update them, so I just did that. But also, before I run the test, I should show the machines that I'm running. This is a DigitalOcean droplet running the REST API. And so let's go back to the cache stack. So this is what we're testing. This is the cache stack. The full node is this machine right here. It's not doing much. There's a slight uptick right here from just working with the wallet and getting it prepped. Also an uptick in bandwidth as a result. But it's still, memory usage is low, CPU usage is low. And then the indexer is what we are testing, and so that's an Ninsight. We don't have any direct metrics for that, but this test is being run from a DigitalOcean data center in New York against whatever wherever that indexer happens to be. So it's exactly the same setup against the OpenBazaar infrastructure. And then the REST API is this machine right here. Again, CPU usage and memory usage are minimal. And so I don't. This test should not stress this box or this box. It's only intended to stress this box, but it's a system test that tests the system as a whole. Okay, so with that, let's give this another go. Okay, so yeah, that was the problem. And it's generating 200 addresses. And so it's got 10 UTXOs. Just to refresh on how this test works, it's got 10 UTXOs that are already confirmed in blocks. And it's spending a UTXO and then trying to spend the resulting child UTXO. And it will do that 20 times. And then it will move on to the second UTXO, the second confirmed UTXO. And so what you end up getting is 10 confirmed UTXOs spent 20 times each from children. And that's the part where the indexer is rapidly updating. So this is pretty noisy, but let's see. You can see, UTXOs is 0. It's trying to get the UTXOs, but it's not found. And then it tries again, and here it found the UTXO, so then it spends it. And that was TX20. Looks like it's on 35. This is going quite fast. Looks like it's averaging around 1.5 seconds. That one was really fast. So yeah, I will pause the video here and until it gets up to 200 and the test completes, and then we can see what the average across these 200 transactions was, and we can also see look at the statistics or the metrics of the machines and see if there's anything there to see. I don't expect there to be. Okay, the test is complete. And the average came to 1.76, 1.76 seconds is what I would say. Interesting thing I noticed as it was going by, you can see these last few were very fast. They came back, they only had one failure. That one had no failures, came back immediately. 1, 1, 1, 1, 2, 1, 1, 2. So like some of the, usually it's really fast, but there's some of these. Let me see. Yeah, so there's one. 1, 2, 3, 4, 5 attempts before it finally got one. So 3.8 seconds for that transaction. I saw one go by that took 7 seconds. So this is one thing I'm just noticing that's setting it apart. Blockbook and OpenBazaar's fork of Blockbook were really consistent, and they were just really consistent in behavior. And in this, the Ninsight is a little less consistent. Still fast. In fact, it would be significantly faster if it was more consistent. But it's the inconsistency that's driving up this average speed time. So if we were to plot this using standard deviations, that would really illustrate the difference between Ninsight and Blockbook. So I just thought that was interesting. Let's take a look at the stats. Refresh this page and refresh this page. So full node CPU usage, you can see, bloop, yep, spiked right there. And which is, I don't think that's necessarily the test we ran. That's pretty far back, and I've never seen that behavior before, so I'm not sure how to explain that actually. There could be a spike of traffic on the network. That actually is what it looks like, because it looks like there's a lot of bandwidth. And just that little spike on the bottom, I think, is the test we just ran. And REST API also wasn't stressed at all. You can see a spike in the bandwidth That's from the test we ran. So these are all on the same time scale. So, yeah, just that little spike is the bandwidth we used for the test. And this spike here is too old to be part of the test. So yeah, but either way you cut it, there's no significant impact to the REST API or the full node in this test, which is consistent with all the other tests that I've done. So I will add this to the data here. This is where I capture the data for test 1 and test 2, and I will add this third test here, as well as a link to this video in YouTube.